Now let's turn toward some applications of game theory and Nash equilibrium. The first one, and probably one of the more common you see out there, is the case of OPEC, or cartels, where we have a small group of producers that is trying to monopolize a particular industry. In this case, let's say OPEC with oil. We have a small number of countries that really control the grand majority of the oil supply, say, and they're trying to act like a monopoly, restricting production to drive up prices. Now let's suppose that Saudi Arabia and Iraq are really the only two in this group. Right, so we're going to simplify some just to tell the story. So they get together, they form this agreement, they say we're going to act like a monopoly, we're going to restrict production, we're going to prop up prices, it'll be great. We're going to higher profits that way. But then once they leave the room where they make the agreement, it's remarkably difficult for them to actually enforce it. After all, how does one country force its will on another? War is exceptionally expensive, and it's also true that a lot of, say, the sanctions and the like that we could put on others is also exceptionally expensive. So it's probably not worthwhile to do much to actually enforce the agreement. So really relying on their own good sense in getting them to follow the agreement. But the reality is their own good sense will lead them the other direction. And here's why. Saudi Arabia says, well, let's think about Iraq. They're either going to cooperate with the agreement or not, and it's not really up to me. So suppose they cooperate. In that case, as Saudi Arabia, I can cooperate with the agreement, earning the $5 billion that we agreed. Or I can cheat on the agreement, produce a little bit more, it'll drive the price down a bit, but that's okay. After all, if it drives the price down just a bit, I can sell so much more to offset that. So say I'm earning $7 billion instead. Now this is, on the other hand, very bad for Iraq, because Iraq has restricted production and now are facing low prices. As a result, they might, say, end up taking a loss. Let's say $3 billion. But Saudi Arabia doesn't care about Iraq. Saudi Arabia cares about Saudi Arabia. Since cheating would provide them with a greater profit, they'll go ahead and cheat if they believe that Iraq is going to cooperate. At the same time, if Saudi Arabia believes that Iraq is going to cheat, then they can either go ahead and follow through on the agreement, losing $3 billion, or Saudi Arabia can cheat on the agreement, making it a competitive marketplace where at least they're breaking even. Better to break even than take a loss. So Saudi Arabia then still has a reason to cheat. So it ends up, when Saudi Arabia gets home, it doesn't actually matter what they believe that Iraq is going to do. If Iraq cooperates, Saudi Arabia is better off cheating. If Iraq cheats, Saudi Arabia is better off cheating. Right? So it doesn't actually matter which of the two things they believe Iraq is going to do. Saudi Arabia has every reason to cheat. It ends up, the same is true for Iraq. As a result, we end up with a competitive marketplace where we get together, we make an agreement, we leave, we don't follow the agreement. So it was really, frankly, a waste of time for us to get together in the first place. This is why economists tend not to be very worried about cartels, because they have a tendency to fall apart. Even in cases, it ends up in cases where they do actually manage to work, it's usually because there's some big overriding non-economic issue going on. So for example, they really hate the US or something like that. That can bind them together for a while. But once this passes and economic issues are what they worry about, it ends up the cartel is going to fall apart and end up acting more competitive. The same goes with any type of collusion. We have two firms, firm 1 and firm 2, deciding whether they want to produce 2 or they want to produce 3 of this particular good. Now if they each produce 2, that'll keep the price up a bit, say earning them each $8, so say $4 a piece. If they both produce 3, then that pushes prices way down, so say they earn only $2 a piece, so $6 of profit for each of them. Now, it could also be the case that, say, one of them produces 3, the other one produces 2. In that case, say, profits get pushed down to $3 each. So if you produce 3, you got $9. If you produce 2, you get $6. In that case, firm 1 would say, well, if firm 2 goes ahead and restricts production, I can earn $9 by producing 3 rather than 8 by producing 2. Better to produce 3. At the same time, maybe firm 2 is going to violate the agreement, it's going to produce 3 units. In that case, I may as well produce 3 units because it's just as profitable as producing 2. So in that case, firm 1 has a reason to produce 3 units and no reason to just produce 2. Firm 2 is in exactly the same boat. That being the case, we would expect this collusion to fall apart. Both firm 1 and firm 2 are going to produce 3 units. As a result, we end up with a result that isn't particularly monopolistic. Instead, it's relatively competitive. Another case where we can apply game theory is the positional arms race. With the positional arms race, what matters is your outcome relative to somebody else. So this would be the case with virtually any sport. What matters isn't how well you did, but how well you did relative to someone else. So for playing football, it doesn't matter if I had a really good game, if you had an even better game. I still lose. Right? So what matters is our position relative to others. It ends up this shows up economically quite a bit. For example, the case of executive pay at a bank. So here we have two big banks, Citibank and JP Chase. Now, if the two of them pay the same amount for their executives, then they're going to split the executive talent relatively evenly. On the other hand, if one of them pays more for their executives than the other, the one that pays more will end up with really good executives, while the one that pays less will get stuck with relatively lousy executives. So let's, for the sake of argument, say that if they both pay high, the executives end up with the ones that are paid the extra profit. So it doesn't actually come through to the shareholders, so 0 for each of them. On the other hand, if they both pay their executives less, or a low amount, then that does show up as extra profit. They split the talent evenly. At the same time, they're not paying a whole lot to their executives, so that shows up as profit. Now, if one pays high while the other pays low, whoever pays high gets the best talent, and therefore earns a substantial profit. Whoever pays low has the worst talent, and through mismanagement ends up taking a significant loss. So now let's walk through this. Say, well, what are they going to do? Citibank says, well, if JP Chase pays high, we better pay high. Otherwise, we get stuck with lousy talent, we take losses. On the other hand, if JP Chase pays low, we better pay high. After all, we want to have the best talent we can get. If they're not paying very much, we can pay enough to more than offset the additional expense by having the best talent. So it ends up, in either case, Citibank wants to pay high. Well, the same is true for JP Chase. So we end up with a case where both JP Chase and Citibank are paying high, which is a bad thing for their shareholders, as the money, rather than going to shareholders, goes to the executives. Right? So that being the case, in a case like this, where this would be a case of a prisoner's dilemma, we have a single Nash equilibrium supported by a dominant strategy, and it's also not the best outcome for either player. And so we could improve both players' outcome by changing what the players did. There would be a strong reason for the shareholders to support something like a cap on executive pay. If we can force everyone to pay low, that's a good thing for shareholders. At the same time, it's not a good thing for us individually to start paying low, because of how that drains executive talent from our business to the other one. So this is a case where we could possibly see shareholders calling for limits on executive pay, while at the same time, executives are going nuts because certainly they don't want their pay to be cut. Another case would be something like tobacco companies with advertising. The reality seems to be that tobacco company advertising doesn't actually attract new smokers. Instead, it just leads smokers to change brands. So we can imagine if both Winston and Marlboro advertise, it's not really going to help their profits. They'll just split the market relatively evenly. Whereas if Winston and Marlboro, neither of them advertise, they save the advertising expenses, and at the same time still split the market relatively evenly. So it's going to be more profitable for them. Now, the reason you might advertise is if you can advertise while the other one doesn't, you attract more smokers from that brand, you earn a greater profit, while it ends up take a loss. That being the case, we can go through the reasoning just like we did with, say, the executive pay, and find out Winston wants to advertise if Marlboro advertises, otherwise they take a loss. Winston wants to advertise even if Marlboro doesn't advertise, because that way they can gain this advantage. And Marlboro is in exactly the same boat, also wants to advertise in either case. So we end up with both companies advertising, neither of them making much of a profit, as they're really just advertising to protect themselves from losing customers. Now, all of these are relatively simple cases where we have just two players and just two possibilities, so advertise or not, high or low pay, and the like. It ends up we can use game theory in much more complicated cases, where, say, here we have a stretch of beach. And suppose that people always go to the nearest ice cream stand. And there are two ice cream stands trying to figure out where they're going to set up to maximize their number of customers. The question then is, where do the stands locate? And so game theory can tell us. Now, it might be tempting. Now, go ahead and think about it for a few seconds. I'll talk about the solution here in a second. Okay. So it might be tempting to say, well, the two are going to locate on opposite ends of the beach. They'll split the beach evenly. That seems to make sense. Except it doesn't. Because if one of them locates on the end of the beach, the other one doesn't want to locate the opposite end. Instead, it wants to locate right next. After all, right here, the leftmost arrow would get virtually everybody along the beach to come to them. So that being the case, the rightmost arrow isn't going to just sit there at the end of the beach and say, oh, woe is me. Instead, I'm going to move my stand, I'll leapfrog past the other guy, Right? Move a little bit closer to the center. Well, this person isn't going to stand for it. They'll leapfrog again, and we keep this process going until we both end up right in the center of the beach. This helps to explain things like why we always see gas stations right next to each other. It seems like anytime there's a corner, you don't just have one gas station, you often will have two. Well, it ends up it's this kind of game playing out. We're both of us located in the center of the beach. Now neither of us wants to leapfrog the other, or we'll end up with fewer customers. Right? Game theory gets us to that solution. And it's really all about best responses. If you're near the center of the beach, I want to be near the center of the beach. If you're at the end of the beach, I don't want to be near the center. I want to be very close to you. But that leads you to want to leapfrog me. This whole process is really just looking for a Nash equilibrium. At what point do we stop leapfrogging each other? At what point do things stabilize? It ends up it's when we're both in the center. So game theory is actually a very useful thing. It allows us to look at kind of odd cases like this one, where we're stretched along this continuum and we're looking for a single point out of the infinite number along this continuum. It ends up Nash equilibrium can help to pin that down.